This video is a factoring refresher. This is not going to be part of any unit, not part of any chapter. This is just my way of reviewing you on how to factor. And the reason why I do this is because one of the methods to solve a quadratic equation is to solve by factoring. And I find that it's easier on you if I take just a little bit of time to refresh your memory on how to factor. So let's look at set number one. Set number one focuses on just the greatest common factor, factoring out the GCF. So let's look at question number one. Question number one says 12k minus 18. When we look at these two terms, and that this is a binomial, so when we look at these two terms, what we're trying to figure out is there anything that will divide evenly into both of those? Because that would be my greatest common factor. We're looking for the largest number that divides evenly. 2 divides evenly, and 3 divides evenly. But so does 6. 6 would be the greatest common factor. And because the 18 does not have a k, there's not a variable part to our greatest common factor. So we're going to take the 6, and we are going to divide out the 6 from both the 12k and that negative 18. So 12k divided by 6 is going to be 2k, and the negative 18 divided by 6 is a negative 3, and that's your answer, 6 times 2k minus 3. Now let's look at example number 3. We have 14m to the 6th minus 35m to the 3rd minus 7m squared. So in this example, every single term in our trinomial has a variable, and I'm going to talk about that in just a second. But I first want to focus on just the 14, the negative 35, and the negative 7. So here again, we're trying to figure out what is the largest number that will divide into 14 and 35 and 7. Well, that's going to be a 7. Now for the m to the 6th, the m to the 3rd, and m squared. When we are looking at the greatest common factor, you cannot have a GCF with a variable that's bigger than your smallest one. So m squared is the smallest exponent there, and that is going to be my greatest common factor, 7m squared. And now we're going to divide it out. Also remember that when we are dividing variables, exponents subtract. So you may want to write that in the margins. 14m to the 6th divided by 7m squared. Well, 14 divided by 7 is 2, and 6 minus 2 is 4, so m to the 4th. Negative 35m to the 3rd divided by 7m squared is going to be negative 5, because negative 35 divided by 7 is negative 5. And then for my exponents, 3 minus 2 is 1, so negative 5m. And then for the last term, negative 7m squared divided by 7m squared is going to be a negative 1. No variable left on that one. So there's your answer on number 3. When we are factoring, you always have to look for a GCF first. Make sure that you are always looking for that GCF first. So let's look at set number 2. Set number 2 is factoring trinomials where ax squared plus bx plus c, where the a is equal to 1. So the leading coefficient on your trinomial, on your quadratic, is a 1. Number 5, example number 5 says x squared plus 14x plus 45. I've lost some of my signs in my form here. So x squared plus 14x plus 45. The leading coefficient on this is a 1. There is no greatest common factor in all three of those terms. So to do this, most of your Algebra 1 teachers would have told you to take that last term that's constant, which is 45, and we want to find two numbers that multiply to give us 45 that are going to add to give you the middle term. So it needs to add to give us 14. So again, we're looking for two numbers that multiply to give us 45 that add to give you 14. You may have to go through several things here. So 5 times 9 is 45, and 5 plus 9 is 14. So that works. And the great thing about that is then that is going to set us up for our two factors. So x times x is the x squared. And then you've got a positive 5 and a positive 9. I wrote the 5 again. That would be our 9. And that is your trinomial in factored form. Let's do another one. Number 7 says c squared plus 2c minus 48. Again, the leading coefficient here is a 1, and there is no GCF in this trinomial. So I'm looking for two numbers that multiply to give me a negative 48, that add to give me a positive 2. Well, 6 times 8 is 48, not a negative 48. So if I make the 6 negative, negative 6 times 8 is a negative 48, and negative 6 plus 8 is a positive 2. So I found my two numbers. So this is going to factor into c plus 8 and c minus 6. Couple of things here. Some of you may not see the two numbers right off the bat. You may go through several numbers in that table before you come up with the two that actually work. Also, the order in which we put those together does not matter. I could have written c minus 6 and the c plus 8, and that's the same answer. Looking at example number 9, a squared plus 12a plus 36. Again, the leading coefficient is a 1, and there is no greatest common factor in those three terms. So I'm going to look for two numbers that multiply to give me 36, that add to give me 12. And that one's going to be 6 times 6. 6 times 6 is 36. 6 plus 6 is 12. So this is going to factor into a plus 6 and a plus 6. Or you could write this as a plus 6 squared. Number 11. There is a GCF on number 11, and we're going to factor out the greatest common factor, and it is a 2. So divide a 2 out. 2k squared divided by 2 is just k squared. Minus 16k divided by 2 is going to be minus 8k. And then negative 40 divided by 2 is negative 20. And the reason why that was important is because what that has left me with inside the parentheses is a quadratic with a leading coefficient of 1. So I can factor what's left by trying to figure out what multiplies to give me negative 20 that adds to give me negative 8. So two numbers that multiply to give me negative 20 that add to give me negative 8. Well, there's 2 times 10 is 20. It's not negative 20. But if I make the 10 negative, 2 times negative 10 is negative 20. And 2 plus negative 10 gives me my negative 8. So I have found my two numbers, a positive 2 and a negative 10. To write my answer, it's going to be k plus 2 and a k minus 10. And again, don't forget that GCF that you took out originally has to go out front. All right, let's keep going. In the next set, we've got trinomials. We're going to be factoring a trinomial in the form ax squared plus bx plus c. But in this situation, the a is greater than 1. So our leading coefficient is not 1. On number 13, it says 2x squared minus 15x. That's a plus 18. It's kind of hard to read in this video. I'm sorry, but you have your copy. So again, 2x squared minus 15x plus 18. You're still going to look for greatest common factor first. Don't forget about GCF. There isn't one on this trinomial, on this quadratic. There's not a GCF. So to factor this, what you should do is multiply the leading coefficient by the constant. So to fill in our multiple sum table, which is what I call it, it's a multiple sum, you have to multiply the 2 times the 18. You have to figure in that 2. So 2 times 18 is 36. The sum is still going to be that middle number. So I still need two numbers that add to equal negative 15. So multiply to give me 36, add to give me 15. Let's see. I know that 3 times 12 is 36. And I think I accidentally picked the correct one right off the bat. But how to get negative 15? Well, if I make that a negative 3 and a negative 12, negative 3 times negative 12 is still positive 36. And negative 3 plus negative 12 gives me my negative 15. Y'all, that was an accident coming up with that right off the bat, because there's lots of multiples of 36. 2 times 18, 3 times 12, 4 times 9, 6 times 6. So there's a lot of combinations that you might have had to go through before you came up with the 3 and the 12. Now, here's how I do it. It may not be how you were taught in Algebra 1. If you remember how you were taught in Algebra 1, by all means, you can use that method. Here's how I usually teach factoring a trinomial with a leading coefficient. I'm going to take this 2x squared. I'm going to keep the 2x squared, and I'm going to keep the 18. But I'm going to change that negative 15x using my negative 3 and my negative 12. I'm going to change this to a negative 3x minus a 12x. So basically what I've done is I've changed my trinomial to a 4-term polynomial. And the way that we factor 4-term polynomials is by grouping, which is probably another section. It's not another section. So let me review you quick on factoring by grouping. When we have 4 or more terms, we factor the polynomial by grouping. So I'm going to take these first 2 and I'm going to group them together. And I'm going to take the negative 12x plus 18 and I'm going to group them together. So then what I do is I take the GCF out of both sets. So looking at the first one, 2x squared minus 3x, the greatest common factor is an x. So I'm going to divide that out. That's going to give me x times 2x minus 3. Now, what I'm hoping for is that once I take the GCF out of the second set, what I'm supposed to have left here is a 2x minus 3. In order for that to happen, I need to factor out a negative 6. So negative 12x divided by negative 6 is 2x. Positive 18 divided by negative 6 is negative 3. And the reason why we want these two to match is because that is the new GCF. It's one of the factors. And the other factor is the x minus 6. Let's do another one of those. That's your answer for example number 13. Example number 15. We've got 3h squared minus 19h minus 40. Again, there is a leading coefficient, but there is no GCF. So I'm going to multiply 3 times negative 40 and get negative 120. And I need to add to get negative 19. So 2 numbers that multiply to give me a negative 120, that add to give me a 19. 2 times 60, that's not going to work. 3 times 40 is not going to work. 4 times 30, I don't think is going to work. 5 times, 5 goes into 120. I think 24. This might be interesting. 5 times 24 is 120. And if I make the 24 negative, 5 times negative 24 is negative 120. And 5 plus negative 24 gives me the negative 19. So there's my 2 numbers, 5 and negative 24. I'm going to put, when I write this, 3h squared, I'm going to put the minus 24h first and then the 5h next. And that's just my own personal preference. I like the 5 with the 40. So from here, again, we have 4 terms. We're going to factor by grouping. So you're going to group that 3h squared minus 24h together and the 5h minus 40 together. The greatest common factor in the first set is a 3 and an h. Divide that out, and you get h minus 8. 5h minus 40, the greatest common factor is a 5. It's a positive 5. Divide it out, h minus 8. So that brings us to our final answer of h minus 8 times 3h, and that's a positive 5, so use a plus 5. Let's do one more of these. Let's do number 19. 9x squared minus 12x plus 4. Again, leading coefficient is a 9. There is no GCF, so we're going to multiply. 9 times 4 is 36, and it needs to add to give me negative 12. Two numbers that multiply to give me 36, that add to give me negative 12. Immediately, I'm thinking 6 times 6. 6 times 6 is 36, but 6 plus 6 is a positive 12. But if I make them both negative, negative 6 times negative 6 is a positive 36. And negative 6 plus a negative 6 is a negative 12. So those are my two numbers. So I got 9x squared. Replace the negative 12x with negative 6x minus 6x plus 4. Y'all, the thing is that when there is a negative in the middle, that's when it becomes tricky. Let me group, and then your negative 6x plus 4. So basically, your first parentheses, the GCF, is easy to see. It's a 3x. We're going to divide that out, and you get 3x minus 2. This first term in the parentheses is positive, which means the first term in my next parentheses is going to need to be positive. But in order for that to happen, I need to divide negative 6 by another negative number. And that's the hint that I use to pull out or divide out the GCF here as a negative 2. So negative 6x divided by negative 2 is a positive 3x. And a positive 4 divided by negative 2 is a negative 2. And those parentheses do match. So my final answer is 3x minus 2 times another 3x minus 2, which is the same thing as 3x minus 2 squared. Moving on to set number 4. In set number 4, we're talking about difference of squares. Now, what's going to set these apart is you only have 2 terms. It is a quadratic because it has an x squared. Some of these are going to be a little more complicated than others. But we have these quadratics, and there will be quadratics that we're trying to solve in this next chapter that are difference of squares. So let's look at number 21. It says x squared minus 4. To factor this, there's not really any work to do. It's very quick. It's very simple. It's going to factor immediately into 2 binomials. The square root of x squared is x. The square root of 4 is 2. And then all you have to remember to do is to alternate those signs. And you're done. Done and done. Let's look at number 23. 9x squared minus 25y to the 4th. So one thing I did forget to mention is that with your variables and their exponents, what makes them a perfect square is even exponents. So even exponents are perfect squares. This is a difference of 2 perfect squares. 9 is 3 times 3. 25 is 5 times 5. And then x squared is an even exponent, and y to the 4th is an even exponent. There is not a GCF, so I'm good. I'm just going to go ahead and factor this into the square root of 9x squared is 3x. So I'm going to use a 3x and a 3x. The square root of 25y to the 4th is 5y squared Basically, with your exponents, you're just going to cut them in half. One's a plus, one's a minus, done. And then I'm going to look at the last one here, number 25, 72 r to the 6th minus 2s to the 2nd. Now, there is a GCF on this one, which I hope there's a GCF because 72 is not a perfect square and neither is 2. The greatest common factor is at 2, so I'm going to divide that out. 36r to the 6th minus, that's an s, doesn't look like an s, but it's an s squared. So the question is, what I have left, is it the difference of squares? Well, it's a difference because it's a minus. 36 is a perfect square because it's 6 times 6. R to the 6th is a perfect square because 6 is even. S is a perfect square because 2 is even. So we're going to factor this, again, into two binomials. The square root of 36 r to the 6th is 6 r half that, and you get a 3. For s squared, it's just going to be an s and an s. And again, alternate your signs, plus and minus. And that's number 25 factored. So those are the notes that I have for you for your factoring refresher.